Okay, so hopefully you can all see my Schoology. Here we are in first period. Today is what, Thursday, I think? Almost done with the first week. Fantastic. So we're going to talk about writing equations of lines today. And if you want to use the notes sheets, that's okay. And then here is your practice for today. If you want to practice writing equations of lines, this is of course shorter than the other ones also, but then this is what I need you to do for sure, okay, is this week 1 assignment. This is the one that you're getting your full-on grade for. Everything else is like practice, but this is your graded assignment. Okay, we're only taking 2 grades a week. But if you happen to do all of the other ones, then you get bonus points, okay? So it's been great that y'all been emailing me and submitting them, which may be why I didn't like make it an assignment to begin with. So there wasn't a place to submit it because I knew this was gonna happen. So if you're doing all of your daily things and you're getting those turned in, then you get extra credit on your regular assignments. So it's a good way to get some practice and some extra points to make sure that you have over 100 in pre-calculus. Okay, this is the first year that we've ever offered extra credit on assignments. So before, you know, and those of you that had us in geometry, you can get like 120 for tests. So you always had over 100% if you did fantastic on the test. But we've never done that in pre-cal. So this is the first year that you're able to get above 100 in pre-calculus if you do all the assignments. And of course, you got to get good grades on the test. So this is the one, week 1 assignments is the one that you have to do and turn in, okay? Week 1 assignment PDF. It has, where'd it go? Okay, number 2, this needs to be a less than. Okay, so when you're doing this here, number 2, this should be a less than x, or -3 is greater than x, right? X should be less than -3, and x is bigger than 4. So you should have something going to the outside. So just know that here on number 2, that should be a greater than symbol. So -3 is greater than x, or x is less than -3. Okay, so please write yourself a note. This is a PDF, so I wasn't able to change it. And I don't know where the original document went, so I was unable to edit it. Make sure you change this to a less than, okay, when you're doing the assignment. So other than that, I hope that you watched the video about whatever the video is about. Oh, yeah, graphing. Graphing absolute values. Okay, and this is a terrible copy, so we're not going to look at that one at all. Maybe we'll look at this one better. Let's see what this one says. Nothing? Okay, so from Algebra 1, slope is, of course, y2 minus y1 over x2 minus x1. Okay, the difference of the y values divided by the difference of the x values. So rise over run is the slope. So I'm sure, hang on, let me see if I can pull this up as a Word document so I can write on it. Okay, hang on 1 second. I wish I had a better Adobe. Hang on, so sorry guys, I should have, we had a department meeting this morning and it took a long time. Not that it's my excuse, it's just what happened. Where is all of this stuff? Set notation, conditionals, domain notes. Anyway, okay, so I'm gonna throw it away And we're going to start with a new Word document. Let me do a new share for you. Share screen. Share my Word. Okay, so hopefully you see a blank Word document. Do you agree you see a blank Word document? Okay. All righty. Finally, I know what's going on. Okay, so slope. Hopefully you all recognize slope as y minus y over x minus x. Right? And if we had the points, oh, maybe I can go back in here and look at this. 3, 5, and 4, -2. So between the points 3, 5, and 4, -2. Okay, so we always do y minus y on top. Doesn't matter which one you subtract from which one. Okay, some Algebra 1 teachers are very particular about which way you go. Okay, but as long as you are consistent doing both ways. So if you do the first y minus the second y, you have to do the first x minus the second x. Okay, so 5 minus -2 and 3 minus 4 turns out to be 7 over -1. So 1. So this has a -7 slope. Okay, so hopefully that's pretty clear for you from Algebra 1. You did a lot in Algebra 2 also. So hopefully this is all refresher. There's some other things that we can do as far as writing equations of lines. There is something called the point slope formula, which I believe your worksheet has as PS. There is, of course, your y-intercepts formula. Which probably has another name that's escaping my brain right now. And then there's the hardest one to do, standard form. Okay, so these are the 3 different ways that we can express linear equations. Okay, if we have a point and a slope, so your point is, let's call the point A comma B. And of course your slope is M. So if you know a point, and if you know the slope, then this is the formula that you would use, or the form. I don't know if it's a formula like in physics, but this is the form. Okay, the y thing, of course, goes with the y part, and the x thing goes with the x part. So if you get to calculus and you're trying to write an equation of a line, and that's, I mean, you do that a lot in calculus, believe it or not, writing equations of lines. All you need to do is leave it like this. Okay? Calculus does not need you to expand this out and solve for y. So neither do I. If you want to write something in point slope form, just replace the a and the b with their numbers, right? These will be numbers from this from the given problem, and then m is the slope. So if we were going to do that for this example up here, right, the one that passes through the point 3, 5, or 4, -2, you can pick either one of these 2 points as your A and your B. Okay, it does not matter. Pick either one of those 2 points that you want. Calculus doesn't care, so I don't care. So let's just pick the first one, y minus 5, right, because the B value here is 5, the y there is 5, equals the slope, which was -7, times x minus 3, and 3 was the x value from this equation right here. Okay, so we're using this point in order to write this in point slope form. We could have also used this point over here. There's nothing special about the point 3, 5. We could have also used 4, -2. So in the y-intercept form, that's your traditional algebra 1, y equals mx plus b. So that's slope intercept, or rather y-intercept, because it's telling you exactly, maybe it's called slope intercept. Maybe it's slope, I don't remember, probably slope. Maybe y-intercept, who knows? Does any of you know? Do any of you care? No, thank you very much. Good. Me either. So y equals mx plus b. You know the slope of the line, right? That's the m part, and you know the y-intercept, that's the b part. So to get the slope-intercept form, you would have to take the point-slope form, okay, and distribute this, and then get y by itself, and that would get you the slope-intercept form. Okay, so in calculus, if you start with this, and this is on your paper, and you're good, but then you make some type of an algebra mistake, and you screw this up, then you get the problem wrong. Okay, because you did some type of an algebra mistake, and it's not the same equation here as it was there. Okay, so in calculus, if you get there, they're going to tell you just to write this down and not try and simplify it. Okay, because the calculus people don't care. So start now, not caring. Just kidding. But seriously, don't care about simplifying that. Okay, and then there's standard form, which nobody ever uses, except for really mean people. Want it in standard form, where you have your positive x value, okay, so x is positive over here, and then you have a b value in front of y, and then you have equals c. So you have standard form, which, by the way, the shorthand for standard form is STD, which stands for something else in health class. So ax plus by equals c is the standard form of a linear equation. Okay, you get no information from this. It's not helpful at all. Okay, at least in slope intercept, you know the slope and the intercept. In point slope, you know a point that it goes through in the slope. So they're much more user-friendly, they're much more informative, okay, than the standard form, which is not informative at all. Okay, so now let's go back and see about these absolute value equations. Where did it go? Here it goes. Arg, I have a touch screen at home and I keep trying to touch the screen and make it go up, and it's driving me nuts. In addition, at home, I have one of those gooseneck sinks, gooseneck faucets in my sink that's touchless. It has like a sensor underneath, so anytime I see a gooseneck faucet, I always try to turn it on by not touching it, and it's ridiculous is what it is. I wish Anywho, that's the way my brain thinks, sorry. I'm writing down this other one from the notes, 5x plus 3, negative 3, 2. Because a lot of this is about parallel and perpendicular also. So of course, hopefully you remember from Algebra 1 and Algebra 2, I guess. I haven't taught Algebra 2 in forever. But parallel lines have the same slope. Same slope, different intercept. And of course, perpendicular lines have negative reciprocal slopes. So you're going to get introduced perpendicular are also known as this special engineering word. Okay, so I had a question about this the other day. Someone was working ahead. They asked me what a normal line was. Well, normal in engineering world means perpendicular. Okay, so if you're ever asked for a normal line, that's talking about the perpendicular lines. And perpendicular lines have negative reciprocal slopes. Negative reciprocal. So if we're asked for something that's normal, you're being asked for the perpendicular. So if we had this equation was from your notes, so 5x plus 3, and it went through the point negative 3 comma 2. So the notes asked you to write a parallel line and a perpendicular line. And we are going to do that in point slope form, just so we can practice being frugal. I'm not going to say lazy, frugal. So y minus something equals something times x minus something else. So this will be the parallel line. And parallel lines have the same slopes. So you come over here and you say, all right, here's the slope of my given line. That means it's going to be the slope of my parallel line. Okay, same slope. And then here is your x value. So that goes in here with the x. So -3 comes in here. And then +2 is the y value. And now my lines are getting all kinds of crazy. And it ends up over there. So this is the equation in point slope form of the line parallel to 5x plus 3. Okay, I'm sure it has a different intercept, but we're not going to worry about that because that would cause us to do some more algebra. And we don't want to do that. Okay, so then over here, let's do the perpendicular one or the normal. Let's use this word normal. The normal line. Normal means perpendicular, so you can say either one that you want to. So we have our general form, right, with our y minuses. So we put this in here. Y minus something equals something times x minus something else. Now the beautiful thing is that your 3, 2 doesn't change. So the 2 still goes here and the -3 still goes there. Okay, your point hasn't changed, but if you want it to be perpendicular, the thing that does change is going to be your slope. So this has a +5 slope, and that of course gets negatively reciprocaled. +5 as a reciprocal is 1/5, and it has to be negative. Okay, so there's a little bit of algebra to review, writing an equation of a line. Normal means perpendicular. Okay, that's probably the only new thing that you're going to get from today. Normal means perpendicular. So I'm going to go back over to the worksheet and get the other equations for our absolute values. 2x minus 4, 4 minus 2/3 x plus 2. Insert blank page. Draw. Okay, so now here's the hard stuff that we haven't had to do for a while, and that's write a piecewise or write linear equations from an absolute value. So I don't know if you guys have done this in Algebra 2 or not, so I'm just going to assume that you haven't. If you have, then fantastic, you're brilliant and ahead of the game. But if you haven't, then you're right in the game where the rest of us are also. Okay, you're right on track, exactly where you're supposed to be. So you're going to be given, and in the notes you're given, this absolute value equation. That's, as I don't think it says, maybe it says y equals, which is fine. Y equals the absolute value of 2x minus 4. So hopefully maybe you watched the video yesterday about being able to sketch the graph of this. So hopefully this will be no problem for you to sketch the graph of it, because here's my amazingly straight lines for my grid. Okay, I am like 98% visual learner, so if I can see, I'm better at doing stuff. So, which is why geometry was fun for me, because I could see it all. It was good. So 2x minus 4. Okay, so one thing that we did on that video was we first found the x-intercept. So to find the x-intercept, you plug in y equals 0. So 0 is the absolute value of 2x minus 4. Okay, so 0 is 2x minus 4. So 2x equals 4. So this has an x-intercept of positive 2. Okay, now the rest of this sketch that we're going to do comes from this slope. Basically, we have right here a linear equation, right? This is y equals mx plus b, sort of. Okay, but not really. So the slope of this is going to be positive 2. So we should be going up 2 units and left 1 in order to get some more points. Up 2 units, left 1. Okay, we could also make a t-table, okay, with x's and y values here. Right, we can plug in all these values for x. If x is 0, y is 4. If x is 1, y is 2. You know, things like this. If x is negative 3, y is 10. Right, so if you don't know exactly what this is doing, you can always plug in values into x. Okay, evaluate this and then take its absolute value. So that's on the left side. Now the right side, since this is its only intercept, means this is the vertex. So you go 2 up and 1 to the right. Okay, so there was more explanation about how to sketch this on that video from yesterday. Okay, so if you're wondering how I'm doing it, please go back and watch that video. Okay, so once you get a little sketch, once you get a sketch of your absolute value, now we can do what we've been asked to do, and that's write some linear equations. Okay, so I did this in color on purpose because one equation is from the orange part of this line, and the other equation is going to come from the pinkle part of this line. Okay, that's pink and purple, pinkle, right here. So looking at the orange part, we have 2 equations, right? We have an orange equation, which I'm going to write here. And then I have this pinkle equation, which I'm going to write here. Okay, now always when we're talking about this as a piecewise function, okay, we're taking pieces of 2 different equations and we're putting it together. Okay, this is the Frankenstein's a monster. I guess Frankenstein was the doctor. His monster didn't really have a name, but he called it after himself, the Frankenstein monster. At least, I don't remember. Did he have a name? How many of y'all have read Mary Shelley's Frankenstein recently? Maybe this year? Anyway, we'll call him this is the Frankenstein monster of writing equations. So we have an equation on the left, right, orange, and we have an equation on this side that's pink. And right down the middle, okay, this is kind of the fence in between my yard and this yard, the 2 orange and the purple yards, the Hatfields and the McCoys, the Capulets and the Montagues. Okay, separate their houses by this nice fence. Okay, this fence is your conditions. So if we're on the left of the fence, positive 2, right? If we're on the left of the fence, we're going to do the orange equation. And if we're on the right of the fence, we're going to do the purple equation. Okay, so that's probably the easiest part, is putting in this condition, because every absolute value equation has a condition, right? Where are we switching from one side to the other side? From the orange equation, where does the orange equation stop and where does the purple equation begin? Okay, it's not gospel. Okay, we won't find this in the Bible or anything, but I traditionally put the equals on the top one and the not equals on the bottom. Okay, one is always equal and one is not equal. Don't make them both equal. One is and one isn't. I don't really care which one you do. Okay, whichever one you feel like doing. And in my brain, I was taught as a junior to write the left equation on top and the right equation on bottom. So that if you go from left to right, you go from top to bottom. That was just the way that I was taught, and I haven't seen it change anywhere else. So I think this is pretty standard stuff. Anywho, back to writing equations. We need to have 2 things, a slope and an intercept. So if we look at this equation here, and you make your little steps, slope is y over x. So we go down 2 units and right 1 unit. Okay, and then down 2 units and right 1 unit. That means this has a slope of -2 because it's going down and left. This is a negative slope. And we can tell that it crosses the y-axis at +4. Okay, -2x plus 4 is this equation for the orange line. Okay, so we can count the slope down and over, that's the slope, and then we can count where the y-intercept is, and that's right here. Okay, so we're writing a linear equation from a graph, basically, from a graph. Now on the other side, we're going to do the similar thing. We can count this one's slope, rise over run, and hopefully you see this is a +2 up 1 over. So this one has a +2x. And if we were to continue on right down here, in order to figure out where it actually crossed that y-axis, we see that it would cross at -4. Okay, if we were to have continued this purple line all the way down until it hits the y-axis, it's at -4. Now take a look-see. I want you to make some generalities from this, if you notice. Okay. We had started with a 2x minus 4 linear equation. Whoa, geez, right? 2x minus 4 inside of your absolute values. Okay, and on the left side, it's negative. Of course, on the right side, it's positive. So if we look at this equation, right, 2x plus 4, this is basically, if we were to make some generalities, the negative of 2x minus 4. Right? Because this is on the negative side. Negative of 2x minus 4 is -2x plus 4. Okay, so that's going to be the equation here. And then on the right side, we have, well, that's this, it's a positive slope and it goes up and it crosses that. It's a lot right here. Okay, so we can look and see and make sure that your equations kind of match up with what we started with. Okay, if it's basic, I mean, this doesn't have anything around it. There's nothing in front here. There's nothing behind it. It's just an absolute value equation. Okay, this will happen every time. One side is going to be the negative of this, and the other one's going to be the positive. So all you have to figure out is, where is the fence? Okay, what is the x-intercept? Where is the middle of this thing so that I can make it sure that your conditions over here on this side are correct? Okay, now that's only good if we have just straight up absolute value. Okay, the other one, the other example on your notes said y equals 4 minus 2/3 x plus 2. Okay, 4 minus 2/3 x plus 2. So let's see if we can do a quick sketch of this one, even though it has a 2/3 slope in it. Okay, so it's a little bit different. Here we have a positive y and a negative, so let's see what happens here. Okay. We can still solve this for 0 to see where it crosses the x-axis, if at all. 4 minus 2/3 x equal, no, plus 2, plus 2. Okay, so the first thing we do is subtract 2 from both sides, and we get -2 equals the absolute value of 4 minus 2/3 x. Okay, which is an issue. Okay, an absolute value can never be equal to a negative. Okay, this will never be equal to -2 in absolute, because absolute value makes things positive. So there's no number that you can plug in here that when you simplify it and you take the absolute value, it's going to be a negative. So this tells us that there's no x-intercept. Okay, So this will not cross the x-axis at all. So in order to sketch this, we need to come up with another way. So let's make a little t-table. And I'm going to pick x values that are easily convertible to 2/3. Okay, I don't want to get all kind of crazy and plug in like a 1, because then 4 minus, and then I'm dealing with fractions, and we all know no one likes fractions. Okay, nobody likes fractions. So 0 is a pretty good bet. I can do math with 0. 4 minus 0, so this is 4. 4 plus 2 is 6. So when x is 0, y is at 6. Okay, 1 is not good, 2 is not good, 3. Let's try 3. 3 is pretty good, right? I can take 2/3 of 3. 2/3 of 3, like if I had $3 and I want 2/3 of that, that would be $2. So 4 minus 2 because is 2, so this will be 4. So now I know, well, once again, here's my slope, right? Negative 2/3 down to right 3. Down to right 3. It's the graph of this that's been moved 2 units up. Okay, if you remember from your Algebra 2, your transformations, this moves your graph up, this makes the slope funny, and this, well, right or left, and this makes your slope funny. Anyway, I think, let's see, is that what happens when you plug in 6? 2/3 of 6 is 4, 4 minus 4 is 0, yes. So this is in fact 2. Let's see about 9. What happens when we plug in 9? 2/3 of 9 is 6. 4 minus 6 is negative 2, which becomes positive, so we're back up to 4. All right, 7, 8, 9. Okay, so I can find now where my vertex is. That is the worst line ever. Okay, so this is my vertex. I have to find out where it turns around, right? I need to figure out where that fence is from beforehand. So now I know that the fence is here at 6. So we're either x is less than or equal to 6 or x is greater than 6. Those are your two, well, that's your conditions, right? We either have a line to the left of 6 or we have a line to the right of 6. So 6 is the fence. It's important to be able to find that vertex because that's where things change. That's where the lines change. Okay, so we have, let's see, I'll make red be on the left side. So let's write the equation for this red line. Oops. Okay, so hopefully you can see this is a down to right 3 slope. Right, and it's negative, so negative 2/3. The same slope as we had over here. But this one crosses at 6. Right, the y-intercept here is 6. And on the other side, we're going to do it in green. Sure, why not? Awful. So this one has a positive 2/3 slope. And if we were to continue on, right, down to over 3, down to over 3, we find that this would cross the y-axis at negative 2. So let's see if our general statement from before holds true. Okay. 4 minus 2/3 x plus 2 turns out to be negative 2/3 x plus 6. Yes, is this the equation that we had for right here? Okay, the exact same one if you just took the absolute value bars off. Now the other equation is if we make it negative. So the negative 4 minus 2/3 x plus 2. Right, so negative 4 plus 2/3 x became 2/3 x minus 2. And that's exactly what we got over here. Okay, so you can always check and make sure, right, if you're trying to do this without graphing it first, okay, right? There is a way to do it without graphing it first, and that's by making one positive and taking it as it is, and making the other one negative, and then combining, okay? You just still have to figure out where that middle fence is gonna be so that you can get this part of your equation right. Okay, because every equation needs to have a linear part and it needs to have this condition. Okay, where does it change and go to the other way? Circle. Okay. Were there any other examples on there? I don't think there were. Let's see. Example 1, example 2. No more examples?